From software testing, October 27, Quiz1 2024. Consider a control flow graph of G. G is a control flow graph of which is a set of vertices and edges, where the set of vertices are 1 to 7 and set of edges are given list of 7 edges, and the initial vertex is v0 equals to 1, that is starting node is v0 equals to 1 and the final vertex vf is 7. Starting vertex, final vertex, and the how many prime paths are present in the given control flow graph. So they are asking to find the prime paths. So generally, what is a prime path? So prime path, PP represents the prime path. So first one is prime path is a simple path, possible simple path, longest possible simple path, and this prime path cannot be extended. Okay. So what is the simple path? So we know the simple path. Simple path means so no nodes are repeated. Repeated except first node and the last node. Okay, except first node and last node. So that is for a simple path, no loops are possible. No loops. You can remember these 2 points is enough for simple path. So that is, for example, simple path we considered 1, 2, 3 and 1. So this is a simple path. Why? So no nodes are repeated except the first node is 1 and the last node is 1. So this is a simple path. For example, if the simple path is 0, 1, 2, 3 and 1. So is this a simple path? No, because 1 is repeated in the middle, right? 1 is repeated in the middle. So it's not the simple path. And these prime paths will cover all simple paths. And prime path is also this one, longest possible simple path. No loops are possible, so except in the middle. So loops are allowed. For example, 1, 2, 3, 1 is a loop, right? For example, 1, 2, 3 and 1. In simple path, 1, 2, 3, 1 is allowed because 1, 2, 3, 1 is a loop. That is, if the simple path starting with initial node, final node is 1 is allowed. Only loops with repeated first and the last nodes are same nodes are repeated allowed. Otherwise, in between the nodes, the nodes between first and final and the initial nodes is not the prime paths. Question: there are 7 vertices, right? First we draw the control flow graph. 7, 1, that is the initial vertex. Starting point is arrow, represented with starting point arrow. So this is 1. So there is an edge from 1 to 2. So that is there an edge from 1 to 2. 2 is the second node. And 1 to 5. 5 also there is an edge. That is 5 here. 1 to 5 there is an edge. And 2 to 3. 2 to 3. Here it is 3. 2 to 3. 2 to 6. So there is an edge from 2 to 6. First we draw the control flow graph. CFG. And 3 to 4. Edge from 3 to 4. Fourth node. And 4 to 2. 4 to 2. So that is back edge, 4 to 2 and 5 to 5. So 5 to 5 means it is a loop. 5 to 7 and another node is there. So 7, 5 to 7. So they mentioned 7 is the final node. Okay, 5 to 7 and 6 to 7. Final vertex 6 to 7 and the final vertex we represented with double circle, right? This is the double circle. So node number 7, final node. This is the final node. Final node. Okay, this is the control flow diagram from the given vertices and the edges. So they are asking to find the prime paths. Prime paths present in the control flow graph. For this, first we want to find the simple paths. That is, all the possible simple paths are prime paths, right? So we want to find the simple paths. Simple paths of length. So that is simple path with length equals to 0. First we want to find the simple path with length equals to 0. Length equals to 0 means that node only. There is no path, right? Length equals to 0. That is node 1, 2, 3, 4, 5, 6 and 7 nodes. So that these are the list of we represented with square brackets because every path is represented with a square bracket. All these are simple paths of length 1, length 0. And next one, find the simple paths of length 1. First starting from 1. So that is 1 to 2 is a simple path of length 1. And 1 to 5 also. 1 to 5 is also a simple path of length 1. So node 1 is completed. Node 1 completed. For what are the simple paths starting from node 2? Node 2. Okay. So 2 to 6 there is an edge, right? 2 to 6 is a simple path. And 2 to 3 there is an edge. 2 to 3. Okay. 2 simple paths. Only there are 2 simple paths from 2 and number of simple paths starting from 3. 3 only 1 is there, that is 3 to 4. Only 1 simple path. Next the number of simple paths starting at 4. 4 means only 1. 4 to vertex 2. 4 comma 2. Simple path starting from 5. 5 to 7. 5 to 7. So very important, you can write exclamation mark because this is the end path. After 7 it cannot be extended. So which paths are ending at the 7, you can, that is the final node, right? The paths ends with final node, final vertex, that is VF, are represented with exclamation mark. Okay. 5, 7. This is the first path starting from simple path starting from 5 and another loop is there 5 to 5. 5 to 5 and again loops are represented with star. This is also simple path because the initial vertex is 5, final vertex is also 5. These are yellowed. This is also a simple path. Okay. Simple path starting at node 6 is 6 to 7. So this ends with any final node, that is exclamation mark. Only 6 to 7, only 1 is there. And the node starting from 7 is not possible because this is the final node. So there are no simple paths starting with 7. That is length equals to 2. That is the number of simple paths. The simple paths of length 2. So first we start at node 1. 1 to length 2 simple paths, that is 1 2 3. This is the first simple path, 1 2 and 3. This one 1 to 2, next 1 to 5. Okay, 1 2 3. Next extend 1 to 2 to 6 also. Okay, first we extend the length 1 to path to next node of which becomes the length 2, that is 1 to 2 is one node, 1 2, next 1 to 6, right, 1 to 6. So 1 to 2 is completed. Next 1 to 5. So 1 to 5 is 157, 157 exclamation mark, only 157. We cannot extend. 155 is not a simple path. Okay, next we extend this path 2 to 6 path. So 2 6 7. Okay, 2 6 7. Next 2 6, only one path is possible, 2 6 7. Next we extend 2 to 3, this one, 2 3 4, 2 3 4, 2 3 4, 2 3, only 2 3 4 is possible. Next we extend this path 3 to 4, that is 3 4 2, 3 4 2, only one path is possible, 3 4 2. Next 4 2, 4 2 6. Next 4 2, extend this to 6, 4 2 6, this one, 4 2 6. Next 4 2 2 3 is also possible, right, 4 2 3. So other paths are not possible. Next 5 cross 7, 5 7 we cannot extend because this is the 7 is the final node. So for this no paths are possible to extend. Next for 5 5, it is a loop. For this loop also no paths are possible. Okay, no paths are possible. And these are, and if we possible 1 5 5 7, it's not a simple path because 5 is repeated. So 1 5 5 7, which is not the length 3, right, this is length 3. 1 5 again 5, because it's not a simple path. Here the 5 is repeated. For 6 7, 7 is the final node, no simple paths are possible. Equals to 3, right, L equals to 3. So in this graph, in the control flow graph, if we extend the simple paths of length equals to 2, that is this path, if we extend this path to next node and the path becomes length equals to 3, right, if we extend only one node it becomes the length 3. That is first we start from this path 1 2 3, this path. So that is we extend the length equal to 2 path 1 2 3 to the next node, it becomes the simple path of length 4, that is 1 2 3. We can extend 4, right, 4 1 2 3 4. Next, is it possible to extend another node 1 2 3? So 1, that is 1 2 3. After 4 is possible, no other nodes are connected to 3, so it's not possible to extend after 1 2 3 only. Is 1 2 6. So extend 1 2 6. Simple paths of length 2 1 by 1. 1 2 3 path 1 2 3, this one, and path 1 2 6, this is part 1 2 5 7 to the next node extend. Okay, next we are consider the path 1 2 6 of length 2. So 1 2, so that is 1 2 6. After we extend to 7, right, so 7. it will become simple path of length 3. It is ending with final vertex, so it ends with the exclamation mark. It cannot be extended, so this path is cannot be extended. So next one is 15157. so 157, it's not possible to extend because it is the final vertex, it cannot be extended. This one 267 path, so 267 is cannot be extended, it ends with final vertex 7. So next one is 234. Is it possible to extend the 234 to next node? That is 234, we extend 2, right? 2, and it is also a loop because 2 starting node is 2 and ending node is also 2. It is a load, so it is a loop. It is the simple path of length 3. Sorry. Next 234 is possible to extend another node 234. So it's not possible. There is no connection between 4 to 7. So only 234 2 is possible. These are completed. Next one is 342. This simple path. So that is 342. Is it possible to extend 3 to 4? 342. 3 to 4 and 4 to 2 and 2 to 6, right? 2 to 6. Again, is it possible to extend 3, 4, 2? So that is 3, 4, 2 and 3. Again 3. Is it a load, right? It is a loop. So is it a load? Starting node is 3 and ending node is also 3 in the simple path. So it is also a load. So it is a loop. Next, is it possible 3, 4, 2, 3? 3, 4, 2, 3. Next 3, 4, 2, 6. Next is not possible. So this is completed. Next we select this simple path of length 2, that is 4, 2, 6. So is it possible to extend 4 to 6 to next node? 4, 4 to 2 and 2 to 6, 6 to 7, right? 6 to 7, and is ending with exclamation mark because the final vertex is there. Next, is it possible to extend 4 to 6, 7? 4 to 6, 7. After 6, not possible. 4, 2, 3, 4 is possible, right? 4, 2, 3, 4 is possible, and it also a loop because starting node is 4, ending node is also 4. These are length 3 paths and length equals to 4 path, and extend the length equals to 3 path to next node. So these paths to extend to next node, it will become length 4. 1, 2, 3, 4. 1, 2, 3, 4. Again 2 is coming, right? 2. So 2 is at the middle and 2 is at the end node. So it's not a simple path. One is 4. It cannot be extended. So this is a loop, cannot be extended. This is also a loop, cannot be extended. Loops are cannot be extended. These are loops, cannot be extended. This is the end, cannot be extended. Final vertex. Only this one is there. Only. So all are not possible. This is also not possible to extension. So this path is only we will check 3, 4, 2, 6, right? So that is 3 to 4, 4 to 2, 2 to 6. It can be extended to 7, right? 7, and it cannot be extended. This is the length of path 4. And again, is it possible to extend? After 6, it cannot possible to connect to any other node. Only 7. So only one path is there of length 4. From the simple paths, the prime paths are maximal length of the simple paths. So the prime paths are maximal length of the simple paths. Select from length 4 onwards. So we go reverse. So length 4, length 3, length 2, length 1 and length 0. Okay, we will go reverse. Is it easy? So first prime path is 3, 4, 2, 6, 7. Okay, this is the prime path. So next one is prime paths of length 2. This is length 4, length equals to 4, only one prime path. Next we will check for length equal to 3. So this is also a first prime path. So that is 4, 2, 3, 4. This is a loop. This is also a prime path. This is the prime path. Next one is 4, 2, 6, 7. Is covered anywhere? 4, 2, 6, 7, right? Here, right? So 4, 2, 6, 7 here. So it's not a prime path. It's not a prime path. So next 3, 4, 2, 3 is covered anywhere in the prime paths? No. So this is a prime path. Third one is 3, 4, 2, 3 is a prime path because it is not covered in the any other prime paths of length 4. Next one is fourth one. 3, 4, 2, 6 is covered anywhere? Right. Here 3, 4, 2, 6 is there, right? So it covered. It's not a prime path. So this is the prime path. This is the prime path. This is also prime path. 3 prime paths. So next 2, 3, 4, 2. So it's not covered anywhere. So this is also a prime path. So 2, 3, 4, 2 is a prime path. So next 1, 2, 6, 7 is a prime path. Yes, it is a prime path. It's not covered anywhere. Fifth one is 1, 2, 6, 7 is a prime path. This is a prime path. Next 1, 2, 3, 4 is covered anywhere. Is also a prime path. It's not covered anywhere. So this is also a prime path P. So 1, 2, 3, 4 is a prime path. Look at all the prime paths of length 3, right? So next we will go for here prime paths of length 2. So in the length 2, so 1, 2, 3 is a prime path. So 1, 2, 3 is here, right, in the prime paths list. So 1, 2, 3 is covered here, right, in the length 3. So it's not a prime path. Next 1, 2, 6. So 1, 2, 6 is covered here, right? So it's not a prime path. 1, 5, 7 is anywhere covered? 1, 5, 7. No. So 1, 5, 7. 1, 5, 7 is a prime path. This is a prime path. It's not covered anywhere. Next 2, 6, 7 is covered anywhere? Yes. 2, 6, 7 is here, right? So in this prime path 2, 6, 7 is here. So it's not a prime path. 2, 3, 4. 2, 3, 4 in this, right? It's not a prime path. 3, 4, 2. 3, 4, 2 also covered here. So it's not a prime path. Next 4, 2, 6. So 4, 2, 6 here. It's not a prime path. 4, 2, 3. 4, 2, 3 covered here and here also. 2 simple paths. It's not a prime path for length 1. So 1, 2 is a prime path? No. Here 1, 2 is here, right? 1, 2 is here. And so many prime paths. In of length 2 also 1, 2 is here. So it's not a prime path. 1, 5 is here. So 1, 5 is here. It's not a prime path. 2, 6. So 2, 6 here, right? 2, 6 of length 4. Not a prime path. 2, 3 is covered anywhere? 2, 3 here, right? It's not a prime path. 3, 4 is 3, 4 here, right? It's not a prime path. And also 3, 4 is also here. So 4, 2 is any prime path? So 4, 2 is here. It's not a prime path. 7. So 5, 7 covered here, right? In the prime path 7. 5, 7 is covered. It's not a prime path. 5, 5. 5, 5 is a prime path. Is not covered anywhere. So 8th prime path is 5, 5. It is a star of loop. So it is a prime path. So 6, 7 is a prime path. So 6, 7 is here, right? So it's not a prime path. Of 1 to 7 are covered in all the prime paths. So these are not prime paths. So total number of prime paths are 8. They are asking to calculate the total number of prime paths. Answer for this question is, so answer is C. So this is the correct answer. Okay.